everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations. So let's get going. Problem solve y double dash minus 4y dash plus 3y equals to sin 3x cos 2x or d square minus 4d plus 3 into y equals to sin 3x cos 2x. Okay, both the equations are same. We know that we can write y double dash as d square y by dx square. Here x is a independent variable and y is a dependent variable, right? Minus 4 into dy by dx plus 3y equals to sine 3x. Likewise, we can write this equation as we know the differential of it equals to d by dx, then d square will be d square by dx square, right? Now we'll multiply the three terms with y, then we'll get d square y minus 4 dy plus 3y equals to sine 3x cos 2x, right? Now we can write d square y as d square y by dx square minus 4 into dy as dy by dx plus 3y equals to sine 3x into cos 2x. If you notice, you're having same equations, right? Both are same. Now identify the highest derivative. Now let's find order and degree of the given equation. Identify the highest derivative here. D square y by dx square is the highest derivative, right? So 2 will be our order. And the highest power of the highest derivative is our degree. Degree is 1, right? Now coming to the problem. So I'll consider this equation. Solution. Given differential equation. Y double dash minus 4y dash plus 3y equals to sine 3x into cos 2x. You can also write this as d square y by dx square minus 4 into dy by dx plus 3 into y equals to sine 3x into cos 2x. Okay, now let's take y common from all these three terms, or let's replace d by dx by differential operator d. Then d square by dx square will be d square, right? Then we'll get d square y minus dy plus 3y equals to sine 3x into cos 2x. Now take y common from all these three terms. We'll get d square minus d plus 3. Here you're having 1 4, right? Okay, d square minus 4d plus 3 into y equals to sine 3x into cos 2x, right? Which is this equation. We got this equation, the equation in operator form otherwise, which is in operator form. F of d into y equals to q, where f of d equals to d square minus 4d plus 3 and q equals to sine 3x into cos 2x. Now we need to find the general solution to the given equation using y equals to yc plus yp. We know that yc is a complementary function. We'll get this using the the roots of auxiliary equation of homogeneous equation of the given non-homogeneous equation. Simply by equating RHS to 0, we'll get f of d equals to, or f of d into y equals to 0. Okay, and we'll find yp using 1 by f of d into q. So firstly we'll find yc using the auxiliary equation of the homogeneous equation of the given differential equation. Right, now the auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d equals to d square minus 4d plus 3, right? Now let's replace the differential operator d by m, then we'll get f of m equals to m square minus 4m plus 3. Then auxiliary equation becomes m square minus 4m plus 3 equals to 0, right? Now we need to find roots to this auxiliary equation. Split this minus 4m as minus 3m minus m plus 3 equals to 0. Now take m common from the first two terms, we'll get m times m minus 3. And take minus common from the next two terms, we'll get minus of m minus 3 equals to 0. You notice you're having m minus 3 in both the terms, so let's take m minus 3 common, then we'll get m minus 3 into m minus 1 equals to 0. Now we equate each factor to 0. If you equate m minus 3 equals to 0, okay, from m minus 3 equals to 0, we'll get m equals to 3. And from m minus 1 equals to 0, we'll get m equals to 1. So our roots will be m equals to 3 and 1, or m equals to 1, 3. Right? We got the roots which are real and distinct. We know how to write complementary function when two roots are real and distinct. Okay? If m1, m2 are two roots which are real and distinct, then a complementary function will be some constant into e power one root into x plus another constant into e power another root into x. Now coming to our complementary function, therefore we have m equals to 1, 3, right? Which are the roots of our auxiliary equation f of m equals to 0, right? Which are real and distinct, or real and different, we can say. Now let's write complementary function to our problem using the roots. Okay, m equals to 1, 3 are the roots, right? Complementary function is yc equals to c1 e power 1 root into x plus another constant into e power another root into x. Then yc will be c1 e power x plus c2 e power 3x. Therefore yc equals to c1 e power x plus c2 e power 3x. Now let's find particular integral. We know how to find particular integral using 1 by f of d into q is equals to, we have one f of d square minus 4d plus 3, and q is sin 3x cos 2x. We know that 2 sin a cos b equals to sin a plus b plus sin a minus b. Then if you take this 2 to RHS, we'll get sin a cos b equals to 1 by 2 into sin a plus b plus sin a minus b, right? Now for a equals to 3x and for b equals to 2x, we'll get sin 3x cos 2x equals to 1 by 2 into sin, replace a by 3x, then we'll get 3x plus 2x Plus replace, okay, a by 3x and b by 2x again. Then we'll get sin 3x cos 2x equals to 1 by 2 into sin 3x plus 2x is 5x plus sin 3x minus 2x is x, right? Therefore, sin 3x cos 2x equals to 1 by 2 sin 5x plus sin x. Fine. Since sin 3x into cos 2x equals to 1 by 2 into sin 5x plus sin x, now we can replace q by this. We'll get 1 by d square minus 4d plus 3 into 1 by 2 into sin 5x plus sin x is equals to, write the constant first, 1 by 2 into 1 by f of d into sin 5x plus sin x. Also you can write this as 1 by 2 into 1 by f of d into sin 5x plus 1 by f of d into sin x. Now we have yp equals to 1 by 2 into 1 by f of d square minus 4d plus 3 into sin 5x plus 1 by f of d square minus 4d plus 3 into sin x. Right? Now we can find each term separately. We can just name the first term as yp1 and second term as yp2 for our convenience. Okay, let's name the first term as yp1 for our convenience and second term as yp2. Now let's find yp1. Firstly, 1 by f of d into sin 5x, right? This is of 1 by f of d into sin ax form. For a equals to 5, we'll find d square, which is given by minus a square, which is equals to minus. For a equals to 5, we'll get minus 5 square equals to minus 25. We should always remember that the denominator is not equals to 0. Okay, we should always get the denominator not equals to 0, or denominator must be not equals to 0 simply. If we get the denominator equals to 0, we'll get 1 by 0 into sin 5x, which becomes undefined. Okay, fine. Now we need to replace d square by minus 25, and let's see the denominator is equals to 0 or not equals to 0. Okay, what we'll get after replacing d square by minus 25. And considering the denominator part, that is f of d. Now replace d square. We get minus 25 plus 3 is minus 22 minus 4d, right? Now we can take minus 2 common from these two terms. Then we get minus 2 times 11 plus 2d. This is not equals to 0, right? So we can replace d square. Replace d square by minus 5 square, which is equals to minus 25. Then we'll just write the same steps here. Minus 25 minus 4d plus 3 into sin 5x, which is equals to 1 by minus 25 plus 3 is minus 22 minus 4d into sin 5x, which is equals to 1 by, now we'll take minus 2 common, we'll get minus 2 times 11 plus 2d into sin 5x. Now we can write this as 1 by minus 2 into 1 by 11 plus 2d into sine 5x, right? Now let's write this 1 by minus 2 as minus 1 by 2 into we have 1 by 11 plus 2d, or you can just write this as 2d plus 11. Okay, it's up to you. I'll just continue like this. Now we'll multiply and divide with 11 minus 2d. See, in the denominator we are having 11 plus 2d, just change the sign, then you'll get 11 minus 2d, right? So we'll multiply and divide with 11 minus 2d to this fraction into sine 5x is equals to minus 1 by 2 into 1 into 11 minus 2d is 11 minus 2d by 11 plus 2d into 11 minus 2d into sine 5x, which is equals to minus 1 by 2 into 11 minus 2d by, see, in the denominator we have 11 plus 2d into 11 minus 2d, which is of a plus b into a minus b form, right? We can write it as 11 square minus 2d whole square, since a plus b into a minus b equals to a square minus b square, right? Into sine 5x. Now this becomes minus 1 by 2 into 11 minus 2d by 11 square (121) minus 2d whole square is 4d square into sine 5x, right? Again, d square appears in the denominator. Again, what we have to do? We have to check by replacing d square in the denominator, okay? And we should remember that the denominator must be not equals to 0. Replace d square by minus 25 and check what you'll get in the denominator. Let's see what we are going to get. Okay, I'm just considering the denominator 121 minus 4d square, and we'll replace d square by minus 25, then we'll get 121 minus into minus plus 4 into 25 is 100, which is equals to 221, right? Which is not equals to 0. Okay, by replacing d square by minus 25, we'll get the denominator not equals to 0. So we can replace d square by minus 25, which is equals to minus 1 by 2 into 11 minus 2d by 121 minus 4 into minus 25 into sine 5x, which is equals to minus 1 by 2 into 11 minus 2d by 121 plus 100 into sine 5x, which is equals to minus 1 by 2 into 11 minus 2d by 121 plus 100 is 221 into sine 5x. Now we can write this as minus 1 by 2 into 1 by 221 into 11 minus 2d into sine 5x, which is equals to minus 1 by 2 into 221 is 442 into 11 sine 5x minus 2d sine 5x. We know that differential operator d equals to d by dx, right? Now we can replace this d by dx. We get minus 2 into d by dx of sine 5x, which means that we need to find the derivative of sine 5x with respect to x, equals to minus 1 by 442 into 11 sine 5x minus 2 into derivative of sine 5x is 5 cos 5x. Then yp1 becomes minus 1 by 442 into 11 sine 5x minus 2 5s are 10. This is the x. Minus 2 5s are 10 cos 5x. See here we got minus 1 by 442 into 11 sine 5x minus 10 cos 5x, right? Either you can leave it like this or you can just take this minus 1 inside the brackets. Then you'll get 1 by 442. Just multiply these two terms with this minus, then we'll get minus 11 sine 5x minus into minus plus 10 cos 5x. That is 1 by 442 into 10 cos 5x minus 11 sine 5x. Okay, you can get any of these two. I'll take this. So therefore, yp1 equals to 1 by 442 into 10 cos 5x minus 5 sine, sorry, this is 11 sine 5x. Now let's find yp2, that is the result of 1 by 50 into sine x. We are going to find yp2 now. One by f of d square minus 4d plus 3 into sine x. This is of 1 by f of d into q form. For q equals to some sign ax, then for a equals to 1, we need to find d square, which is given by minus a square. Then for a equals to 1, we'll get minus 1 square, which is equals to minus 1. Now, let's see what happens by replacing d square by minus 1. F of d, the denominator must be not equals to 0. Okay, you should get the denominator not equals to 0. So now we are going to replace d square by minus 1. Then we'll get minus 1 minus 4d plus 3, which is equals to minus 1 plus 3 is 2 minus 4d. Now we can take 2 common, right? We'll get 2 times 1 minus 2d, which is not equals to 0. So now we can replace d square by minus a square, which is equals to minus 1 square equals to minus 1. Then this becomes 1 by minus 1 minus 4d. Again, we'll write the same steps, okay? Here we are just checking whether we are getting equals to 0 or not equals to 0 after replacing d square by minus 1 in the denominator. Into sine x equals to 1 by minus 3, sorry, minus 1 plus 3 is 2 minus 4d into sine x. Now let's take 2 common. From the two terms of denominator, we'll get 1 by 2 times 1 minus 2d into sine x, right? We can just write this as 1 by 2 into 1 by 1 minus 2d into sine x, or we can write this 1 by 1 minus 2d as 1 by minus 2d plus 1. Now we can take minus common, then we'll get minus of 2d minus 1, okay, which means minus 1 by 2d minus 1. Okay, if you want to show the t term first, you can just write like this, or you can continue here using 1 minus 2d. So we are having yp2 equals to 1 by 2 into 1 by 1 minus 2d into sine x, right? Now, if you notice in the denominator you are having 1 minus 2d. So what I'll do is, we'll just change the sign. Then we'll get 1 plus 2d, right? Now we'll multiply and divide with 1 plus 2d to this fraction. Equals to 1 by 2 into 1 plus 2d is 1 plus 2d by 1 minus 2d into 1 plus 2d. You can just write it as 1 plus 2d into 1 minus 2d into sine x is equals to 1 by 2 into 1 plus 2d by the denominator we are having 1 plus 2d into 1 minus 2d, which is of a plus b into a minus b form. You can write it as a square minus b square, right? Then you get 1 square minus 2d whole square into sine x. We can write this as 1 plus 2d by 1 square is 1 minus 2d square is 4d square into sine x. Again, d square appears in the denominator, so what we'll do, we'll check again. Take the denominator 1 minus 4d square and replace this d square by minus 1 and see what you are going to get. Equals to 1 minus into minus plus 4. 1 plus 4 is 5, which is not equals to 0. Since it is not equals to 0, so we can dare to replace d square. Replace d square by minus 1, then we'll get 1 by 2 into 1 plus 2d by 1 minus 4 into minus 1 into sine x, which is equals to 1 by 2 into 1 plus 2d by 1 minus into minus plus 4 into sine x, which is equals to 1 by 2 into 1 plus 2d by 1 plus 4, 5 into sine x, which is equals to 1 by 2 into, you can just write this as 1 by 5 into 1 plus 2d into sine x. Now we are having yp2 equals to 1 by 2 into 1 by 5 into 1 plus 2d into sine x, right? You can just write this as 1 by 2 5s are 10 into 1 into sine x is sine x plus 2d sine x. We know that d equals to d by dx, then this becomes 1 by 10 into sine x plus 2 into d by dx into sine x. So here we need to find the derivative of sine x with respect to x, which is equals to yp2 becomes 1 by 10 into sine x plus 2 into derivative of sine x is cos x. Therefore, yp2 equals to 1 by 10 into sine x plus 2 cos x. Now we can write yp by replacing yp1 and yp2, the result obtained from yp1 and yp2 otherwise is equals to 1 by 2 into, we have yp1 or the result obtained from yp1 is 1 by 442 into 10 cos 5x minus 11 sine 5x plus result obtained from yp2 is 1 by 10 into sine x plus 2 cos x, right? Is equals to 1 by 2 into 1 by 442 into 10 cos 5x minus 11 sine 5x plus 1 by 2 into 1 by 10 into sine x plus 2 cos x, right? Is equals to 1 by 2 into 442 is 884 into 10 cos 5x minus 11 sine 5x plus 1 by 2 tens are 20 into sine x plus 2 cos x. This is our yp. Now we can find the general solution. The general solution is given by y equals to yc plus yp. Then y equals to, we have yc, c1 e power x plus c2 e power 3x plus yp is 1 by 884 into 10 cos 5x minus 11 sin 5x plus 1 by 20 into sin x plus 2 cos x. This is the required solution. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.